Welcome back. This is Angela Caicedo. I'm a Java evangelist at Oracle, and this is part 2 of the video of getting started with Oracle Java ME Embedded 3.3 on the Keil board. On part 1 of this series of videos, I show you how to get started with the hardware and the software. What this video now is going to focus on is creating your applications. What about the embedded APIs? How can I use them to create my first Java ME embedded applications? Okay, so the board is ready. We already connected to it. We verified that it's actually up and running, and now it's time to start using the IDs and create your first Java ME embedded application for the Keil board. So before we go any farther, these are the 3 things that you have to make sure that you've done before you go any farther on this presentation. You do need Java ME SDK installed on your machine because the emulators that we're going to be using are part of the Java ME SDK. So make sure you install. Again, this is great news for those developers who don't have a board with them. They will be actually able to create applications and test them on an emulator without having a real device. So this is actually great news. For development environment, we're going to be using NetBeans IDE 7.3. Make sure after you install the IDE, you need a plugin. So make sure you get the Oracle Java ME SDK 3.3 NetBeans plugin. Okay. If you install the plugin, you should actually be able to come to NetBeans, go to Tools, and see the Java ME item on the list. If you don't see it, please reinstall the plugin because it just didn't install properly. So you have the Java ME, and we're going to have a custom. We're going to see also that later on we're going to be creating different devices, so you can actually configure multiple devices for testing your application. This is actually the emulators that we're going to be using. Another thing that you should see after installing the plugin is the device selector. So this will allow you to add a device, in this case the Keil board. So how does it work? So we go here. This is just the platform that you have in your system. So in this case, it's actually detecting that I do have the Java ME platform 3.3. So let's add an external device. In this case, remember that the IP address for my board is 10.0.0.11. So this is correct. Next. And hopefully it's going to find your device. Yes, device is available, and then finish. So what you see now is your device is being added to the list of available devices. So this means that you should be able, when we create our first application, we should be able to deploy on the board directly. Okay, so let's create our first application, our first embedded application. If you look at Java ME from the beginning, it is actually an architecture with 2 layers. The lower layer is what we call the configuration, and on top of that we have a profile. So when we talk about the configuration, we're talking about where we define the virtual machine. So this is where we have the definition for the VM, and we actually have just a small set of APIs that allow you to create very basic applications. And on top of that, you have more complex APIs that is what we call the profile, and it actually tailored to devices with certain capabilities. So for embedded, in this case, we're going to be using the information model profile. And for the configuration, we're going to be using the connected limited device configuration 1.1. These 2, configuration and profile, as all the other APIs, are actually part of the Java community process. So for CLDC, we're talking about the GSR 139, and for the information module profile, we're talking about the GSR 228. And so we have configuration, on top of that we have the profile, and then on top of that we have a set of APIs. Some of those are already pre-integrated, like for example the file, I/O, web services, security and trust services, and also the XML. Now, for the information module profile next generation, so it's actually based on MIPI 2.0, but there are few APIs that were not included. For example, the LCD UI, all the UI APIs were not included, the game APIs were not included. And we talk about inlet rather than midlets. And pretty much they have the same life cycle. We have a very nice APIs that are the device access APIs that give us access to the GPIO lines, allow us to do serial communication, and also use the SPI and I2C protocols. This API will actually require particular permissions. So it will actually require root access, and it actually requires the usign, the inlet. As an option, you can actually modify the policy file. So if you go to your micro SD card, the one we previously created, and go to /java/appdb, you will find that file. That file actually defines some domains. And these domains there are a few domains that are unsecure domains. So make sure these two domains allow device access. So this is the permission that you will need to for your applications to use the device access APIs. Okay, so even if your application is untrusted or unsecure or has the minimum privilege, it will actually allow the application to use the device access API. So what we're going to do is we're going to create our first midlet. First, we're going to run it on an emulator, and secondly, we're going to run it on the device. So let's get started. So let's create the first embedded application. So we create a new project as Java ME. And you see here that we have the embedded application as one of the project options. We just name it anything. Let's call it my Keil first. Just take the default one and then finish. Okay, so just the skeleton was created just with the main methods that, for starting the application, pausing the application, or destroying the application. So we're just gonna do some output in the console. So we're gonna do a small loop here. Let me just format the code. A small loop that go all the way to 99, just printing that particular counter. So no rocket science, but we should be able to see it here on the console. So first, we want to run this small sample, your very first and simple application on the emulator. So if you right-click to your project and you select Properties, in the platform, you're going to see the device that we're going to be using. So in this case, I want device 1. This is actually the emulator. So when we run the application, the emulator should be actually, it gets automatically started for us. Okay? So let's run. So right click and run the project. Emulator should come up. Okay, telling us the status. Okay, the inlet is running, and we can see here the output, hello Keil, and all the way to 99. Okay, very simple, but again, this is your first inlet. Even though it's running on an emulator, we can actually see everything here. The emulator is actually pretty cool. It allows us to see the GPIO pins available for these emulators, the ports, if you have the I2C, the SPI, all the information here. And we will actually play with it a little bit more as we do some more demos. Okay, now let's run the same demo, the same code, but directly on the board. So the only thing that we need to do is go back to the project, right click, go to Properties, and then in the platform, let's select external device. Okay, so now we're actually running on the board. Okay, now if we run, okay, we can actually see, let me bring the PADI connections that we have. So remember that we have two consoles. One was the output of the Keil Board, and the second one was the application management software. So if we go to the system output, we can see now that the Keil output is displayed in this console here. Okay, all the way to 99. So my project is actually running on the board. We can actually go to the application management software and do a list. So now we can see that now we have Keil first, that is my application that is actually installed, and it's actually the status is running on my board. So we were actually able to, from NetBeans, deploy my Emulator to my board, run it, execute it, and from my computer I'm actually seeing the output of my application. Okay, good. So the demo was good, just to make sure that everything was working properly with the emulator, with the NetBeans, with the device, but it's actually not very exciting demo. So let's actually use the device access API to really get some excitement here. So there are some pre-configured GPIO pins in the board. So let's start with that, and let's run it again in both the emulator and the device. So what do we have here? So on the board, you can actually see that we have some LEDs. These are actually pre-configured LEDs. We have also a joystick that is actually using I2C protocol, and we also have some buttons. So we have a few GPIO, the LEDs and the buttons. The LEDs will be just for output, and the buttons will be able to get our input. So let's play a little bit with setting the LEDs on and off and getting some reading from the buttons before we actually connect any external hardware to my board. So let's see the code. Okay, so in this case, so again we have my midlet, and the way is it going to work. So you have two ways to actually connect to a GPIO pin. The simplest one is this one over here, where you actually ask the peripheral manager to open a particular GPIO line. In this case, we're going to be using the ID. The information about these numbers, why I'm using number 1 for ID, the developer guide will actually have all that information for you. So just trust me that this is the ID that we need to use. But again, all this information is provided in the developer guide. So what we're saying here is the GPIO pin with ID 1 is actually the LED 1. So what we're doing is we're actually asking the peripheral manager to open a connection there, okay, with the default configuration. So this is the simplest way to actually connect to a GPIO pin. A second method to connect to the GPIO pin is by using a configuration. So in this case, we are actually using the peripheral manager to open a connection to the GPIO pin by giving a particular configuration. So let's see what this GPIO pin configuration is. So it is very simple. It's actually providing more information about the pin. In this case, the first parameter is the port, so you can actually associate multiple pins within the same port. We're not doing that, so we're just going to use port 0. The value for port will be 0. The pin for the second LED is number 2. Then the third parameter is actually the direction. So because this is an LED, we're just actually going to use it as an output only. The fourth is the mode. Then if it's going to trigger anything, and then the original value. So the initial value will be false, so the LED won't be turned on. So what about the bottom? So in this case, what we're saying is we know that bottom is pin number 3. We're actually going to be doing some input because we need to provide some input, and then the default configuration is going to actually trigger, so we're going to listen both edges when we push it and when we release it. So that's what we want to do. And what we're going to actually also do is have a listener, so we're going to be listening to events that get triggered by this particular button. When it gets pressed, it will actually trigger an event, and when it gets released, also trigger an event. So we try to connect to the pins again. As I mentioned, the general one all through a configuration. And then the third one, remember, is the bottom, so we need a listener. So we're going to listen to input, to actions happening on that. So what is going to happen in the main loop? So if everything goes okay, so if we do have connectivity to all the different pins, we're just going to do 20 times. We're going to take the first LED and we're going to turn it on and off. Okay, so we're going to take the previous value and we just have the opposite value of that. So if the LED was on, we turn it off, and if it's off, we turn it on. So very simple. At the end of the cycle, we just want to leave it off. Okay. Now, for listening to the event, so remember that we're going to be listening what happened with the bottom, and the listener is actually myself. So if we go back to the class definition, we have that we are implemented the pin listener. Pin listener only has one method, that is value change. So whenever the value of that GPIO pin change, this method is going to be called. So we're just providing some output. So we're saying, okay, this was triggered, and then what we're gonna do is when we push the button, we're gonna turn our LED, the second LED, on and off. So we have two LEDs. One LED is gonna be turned on and off by the previous cycle, by the previous loop that we defined here, but the second LED is going to be actually turned on and off depending on the value of the bottom. So if we push it, if we turn to 1, we're going to turn it on. When we release it, it goes low value again, so the LED will turn off. Okay. So one of the coolest things that we can do is with the emulator from the SDK, for the Java ME SDK, you can actually create your own emulator. So for example, for this particular sample that I'm using, for this particular code, we have 3 pins, right? One pin with ID 1, okay, and 2 other pins, okay? The second pin, we're using pin number 2 and pin number 3, and this is going to be for output, and the third one is going to be for input. Okay, and so this will be actually the bottom. For the third one, we're actually going to be listening to when we trigger it, both edges going up and going down. Okay, so if we go to Tools, Java ME, we can actually go to the custom device emulator, select the one we wanted, and we can actually create a new one. We can name it anything, so let's call it my Keil. And then in this case, we can actually select what GPIO lines we wanted. In this case, we need 3. So let's create the first one. We need, for the first one, remember ID was 1. Port number, we're using 0. Pin is going to be pin 1. It's going to be for output. Remember, this is the LED, and low for value, for the initial value. Then the second one, pretty much the same thing, also an LED, and we want low for the original value. Third pin is actually the output, the input. This is the pin, so we do trigger both edges, and original value is low. Okay. Now we can actually run the project with that particular emulator. So if I right click, I can actually come here, see that my emulator is my Keil, go to the GPIO pins, see how number one, the pin number one is actually going low and high as we go through the loop. And then the second LED is not changing because it's associated with the button, with the input, right? So here in tools we can see an external event generator. This is actually pretty cool. So you can generate that event. So for the button you can actually push it and release it, right? So in this case the pin is going to be either low or high. So for example, I can actually trigger an input for that pin, so you can actually change it and see how my pin number 2 is actually being changed, right? So we're listening to changes in pin number 3. Once we hear for those changes, we update the pin number 2. Okay, and this is actually happening right here on the listening. Okay, when we change, okay, we actually update pin number 2. Okay, so very nice. Now let's do something more interesting. Let's go and connect external device. In this case there's going to be a Lego airplane. So let's go back to the presentation for a bit. Now the previous demo we're using like pre-configured GPIO lines, for example. But what about if I want to connect my own devices, my own things? In this case, it's going to be a Lego motor that we're actually controlling through the GPIO lines. So what is happening actually, and you can again see it on the developer guide, there are already some pre-configuration, pre-map pins. So for example, LED number 1 also map to PH3 pin, and LED 2 to PH6, and LED 3 to PH7. So what we want to do is we want to move the airplane back and forth, and this is by turning on and off some of these pins. What is very useful is the LEDs will show the status of these particular pins. So if we have a low signal, the corresponding LED will be off, and if we have a high signal on the pin, our LED will be on. So we can actually see what is happening. Okay, so let's have a look at the code before we run it. So it's pretty much what we saw. There is only a minor difference here. For example, remember how you can group different pins into a port? So this is an example how these pins are actually part of port 7. Okay, this is again by specification of the Keil board. It has nothing to do with your program, just with the board. And PH3 is the pin number 3, and PH7 is the pin 7. The rest is pretty much the same. You connect, you open the pin through the peripheral manager using those configurations. Make sure everything goes correct. And then all I'm doing is using pin 1 to go to the left, then wait a little bit, and then going to the right. Wait a little bit, and then go to the left again, and so forth, so on. Okay, so just going to one direction, stop, going to the opposite direction, and we do that twice, and that's pretty much it. Okay, so let's run the demo. Okay, so what do we have here? We have a small Lego airplane that is actually holding a motor. The motor is going to be powered by the GPIO lines from the board. and it will go to the right or to the left depending of the output that we are having. So we're using this pin here. We have 3 volts, we have ground, and we have 2 GPIO lines. This actually will feed an H bridge. The H bridge is allowing us to use the 9 volts from the battery because actually the motor will require 9 volts and the board is only giving us 3.3. So again, we get the power and ground from the board, and we also get the 2 GPIO pins feed the board, and the H bridge will allow us to power the motor using the 9 volts. Remember that these pins here, that is PH3 and PH7, are actually mapped to the LEDs. So what is going to happen is as the values in this pin goes low and high, the LED will actually turn on and off depending on the value. So these LEDs are very useful to actually debugging and understanding what's going on each of the GPIO pins. Okay, so as the airplane moves, we should be able to see the lights on the LED going on and off. So let's run. So you can see the lights going on and off as the 2 different GPIO lines go on and off as we go to the left or to the right with the airplane. Okay, so that's the end of the presentation. I hope you have fun and start working with Java ME Embedded. Remember, you don't require the Keil board. You can actually use the emulator while you get the board. If you get the board, it's actually a lot of fun and you can just keep building really cool and interesting demos. Thank you very much.